In Chapter 6, Section 4, you're going to learn about rational exponents. Now, something you will have to know is, what does the word rational mean? Rational means that you can make it a fraction. So when I say rational exponents, I'm talking about exponents like this, x to the 1/2 power. Now, the same rules apply as they did in Algebra 1. So let's just make sure that you're good, that 5 squared is 25, that 5 to the negative 2 is 1 over 25, and 5 to the 0 is 1. Now, the one that I'm guessing might be concerning you is 5 to the negative 2 power. Let's quickly review negative exponents. Pretend you have 6 to the negative 3rd power. Well, really that is 1 over 6 to the 3rd power, and that is really 1 over 6 times 6 is 36 times 6 is 216. Okay? Negative exponents mean they need to change where they're at. This is a very large review problem from Algebra 1. What you would do is you would take this outside 2 and you would distribute it in to every single thing that you have. So you would get x to the x squared times 2 is x to the 4th. Y to the negative 7 times 2 is y to the negative 14. X to the negative 3 times 2 is x to the negative 6. X to the 2 is x squared. Y to the 9th times 2 is y to the 18th. Okay, let's keep going over some basic rules that you should remember from Algebra 1. Basic rule number 1, fix your negative exponents. I like to circle them when they have to move. Let's look at these. Which of these two need to move? Y to the negative 14th needs to go on the bottom. X to the negative 6 needs to go to the top. And now I will rewrite my problem. That will be x to the 6th in addition x to the 4th from before. That will be on the bottom, x squared, y to the 18th, and y to the 14th because I moved it to the bottom. Notice when I moved the 6 to the top, it became positive. When I moved the 14 to the bottom, it became positive. Now we will combine. X to the 6th and x to the 4th makes x to the 10th. X squared is on the bottom. And now y to the 18th and y to the 14th makes y to the 32nd. The last thing you'll do is you will reduce, okay? See these two? You subtract x to the 10th over x squared. Well, where is the bigger number at? X to the 10th is on the top. So 10 minus 2 makes 8 of them on the top. And we leave y to the 32 on the bottom. There's your quick review from Algebra 1 and your rules about your exponents. All of these rules will need to be learned for the remainder of the section. Moving on to the new topic today. The new topic today is using fractional exponents. All right, let's start when we have a 1 in the numerator and the root comes from the denominator. B to the 1/2 is read b to the 1/2. It is the same thing as the square root of b to the 1st. Moving on, and this is all new to you. B to the 1/3 is read b to the 1/3. It is the same as the cube root of b to the 1st. B to the 1/4 is the 4th root of b, okay? B to the 1/5, guess what? It's the 5th root of b. And that continues on and on. So, it should lead you to believe this. If you ever have 64 to the 1/3 power, that is the same thing as the cube root of 64, which reduces to 4. So every square root Every square root you have ever seen is really just a fractional exponent. Now let's talk about if the number is not 1, okay? Well, b to the 2/3 is just a little bit different. There are different ways to write this. You may take b to the 2/3 and make it b squared to the 1/3 power. Now what would that turn it into? Well, we know the root is going to be the cube, so we could say that that's going to turn it into the cube root of b squared. Or we could write it like this. It's the cube root of b, all of that squared. Either one is acceptable. Let's look at example 1. I like this second method right here much better. So let's try example 1 the way we did this. So let's look at our root. Okay, this is the root. Miss Miles will tell you that's the root because it's at the bottom, just like the roots are on the bottom of a tree. Since 4 is on the bottom, it is the root. So when we draw our root, we put a 4 as the index. Let's put the big base 16 inside. And then let's put parentheses around that and cube it. Now why would I want to do it this way? Because I know that the 4th root of 16 is just 2. And then the cube travels down and I get 2 cubed is 8. Example 2. Let's try the same thing. Let's draw our cube root. That came from the root of 8. And then after we find that, let's square it. Well, I know the cube root of 8 is 2. Bring the squared down. That makes 4. Let's move on. I have x. Alright, so now I have a variable to deal with. Well, I know that this is the 6th root, and I know that x, the 5th, goes inside. You can write it like this, or you can write it like this. With variables, I actually prefer this way. Okay, so let's write better here. Now take a good look at example 4. Do you see the negative exponent? Write down negative exponent, move to denominator. Negative exponent, move to denominator. So what we're going to do now is we're going to put 1 over 64 to the positive 3 over 2 power. That's going to be 1 over the square root of 64. And then we're going to have to take that to the 3rd power. Well, that's going to equal 1 over, what's the square root of 64? 8 to the 3rd power. And that's going to equal 1 over 8 times 8 times 8 is 512. Moving on. Problem 2. Converting between exponential and radical form. Problem A has 2 different problems on it. So let's kind of draw the difference here. It says, what are these 2 items in radical form? Guys, radical form means a square root. Okay? So let's go to x to the 3 over 7. Put your 7 here, put the x here, put the 3 there. Good. Now this one, of course, is being a little difficult because it's in a decimal. So let's say this. Change decimal to fraction. Write down your directions. Change decimal to fraction. And now that's going to be y to the negative. Do you know what negative 3.5 is? Well, that's 7 over 2. Because 7 divided by 2 is 3.5. Alright, now let's fix this. You ready? It's negative, okay, negative exponent. Negative exponent means that it needs to be moved. So you do 1 over y to the positive 7 over 2. When you move it, you change it to a positive. That makes 1 over Now what is that? The square root or not? The square root of the 7th root? The bottom number. It's the square root of y to the 7th. Let's try got it. Got again, 2 problems. See the negative 5 over 8? Alright, the negative 5 over 8 has to go in the denominator. So we're going to do 1 over w to the positive 5 over 8 when we move it to the denominator. That's 1 over the 8th root of w to the 5th. Now what about point 2? Hopefully you know that point 2 is like 2/10, which is really just 1/5. Okay, should you write that down? Probably, if you didn't know it. Point 2 is really 1/5. And how do we write that? That's the 5th root of w to the 1st power. Circle your final answers so that when you study, because I'm hoping you will, you know what the final answer should look like. Moving on. You can tell that I added a lot of my own examples. It's because these can take so many different forms. I want to make sure that I'm providing you with every opportunity I can. Let's say now that you want a radical. Let's say the directions say write it as a radical. That means you can't have any more fractions as exponents. You shouldn't have any negative exponents, but you can have fractions at the very end. Okay, not exponents as fractions, but actual fractions. Maybe it'd be easier if we just practice a few. Write it as a radical. That means a check mark. Okay, so this one is the 6th root of x to the 1st. No problem, right? This one is the what root? The cube root of x squared. No problem so far. Let's look at 13. This one is the 4th root of y to the 5th, but I'm going to take second. You ready? When the inside exponent is bigger, write this down. When the inside exponent is bigger, reduce. When the inside exponent is bigger, reduce it. So, you have 5 y's. You need 4. Let's picture it. 1, 2, 3, 4, 5 of them. How many groups of 4 can you pull out? You can pull out 1 with 1 left over. This is the perfect answer. Okay, example 14. Oh, look at this. I've got 2 the same bases, 1 on the top, 1 on the bottom. Now, which one's bigger? If you've ever had me before, I would ask you, where's the party at? And you would tell me the top. The top is bigger. There's more up here. So what you're going to do is you're going to do 2 over 3 minus 1 over 6. Well, 2 over 3 minus 1 over 6. If you can't do this, you better learn how. Okay, 2 over 3 minus 1 over 6 equals 0.5, which is 1/2. So what does that mean? Okay, since it was bigger, the answer goes on top. So I get x to the 1/2, which is really just the square root of x. What are these in exponential form? Now look what form we're going into. Exponential. So this is radical, go to exponential. 2 problems. Here's the base of x. Okay, what number's on the top? What number's on the bottom? The root's on the bottom, just like it is on a tree. The 3 goes on the top. Let's try it again with y. The root's on the bottom, just like it is on a tree. The 4 is on the top. Let's practice some more. What's the root here? I hope you remember it's a hidden 2. So we write our base, the root on the bottom, the number on the top. Move on. We write our base, the root on the bottom, the exponent on the top. Example 19. the root on the bottom, the number on the top. Put an exclamation point on this one. They tricked you. That reduces. 10 divided by 5 is x squared. Example 20. Your base, the root on the bottom, the exponent on the top. Alright, number 21. Now be careful with 21. I want to show you what I get and I want to show you what's wrong. People will write 3t to the 1/6 power. This is incorrect because it is 3t as a quantity to the 1/6 power. What's even better? 3 to the 1/6, t to the 1/6. 22. All right, let's think about it like this. Put a 1 with your 8, and now I want you to do this. 8 to the 1/5 power, y to the negative 1/5 power. That way, 8 gets its own exponent and y gets its own exponent. Problem 3 is our first word problem. I'm going to pause the video and start a new one.